Okay, very good morning, my dear students. Today we can discuss the continuation of Shannon Fano coding method. Actually, we have started the first type of source encoding technique, namely Shannon Fano coding method, and other technique which we will study regarding your syllabus is Huffman coding. So always note that these two, like Huffman coding has lot of advantages over Shannon Fano coding method, and why like we have lot of various coding techniques, and why we are studying only these two, because we can say that these two comes under lossless compression techniques. Lossless, so no information will be lost. So no use information will be lost by using these two kinds of compression techniques. So that's why these two source coding techniques are considered for your syllabus, because other coding techniques like JPEG, that's for images as well as for the text. Okay, and video players, some of the MPEG like audio. So like those all comes under the lossy compression techniques. But this Shannon Fano coding method and Huffman coding comes under the lossless compression techniques. So that's why in our syllabus we have included Shannon Fano coding method and Huffman coding method. Okay, so in this is the first module of fourth chapter part B. So after completion of that, only one more module is left in the fourth chapter. So it will take two classes. Okay, and today we can try to complete the first module. So already I have initiated, and at the end of this lecture, all the students should be able to calculate the efficiency for Shannon Fano coding method and Huffman coding method, and the source coding advantages you need to know, and what is Shannon's theorem. So here we don't go in detail about the Shannon's theorem, because Shannon's theorem states that the whatever the information rate is always less than or equal to the channel capacity. Okay, so what is the capacity of the channel through which you are transmitting the information? Our information rate. So what is meant by information rate? The number of bits transmitted per second. Okay, so that information rate should be always less than or equal to the channel capacity. So if you have more capacity, that channel can allow our data. Okay, so always the information rate should be less than or equal to the channel capacity. Okay, now let us introduce the source encoder and source decoder. Already I completed this as an element of digital communication technique. In that I told you that source encoder effectively represents the source information in a code or binary format. Okay, generally in the form of zeros and ones. So what is the need of source encoding actually? So by using this source encoding, the data upcoming from the source or the input section what it will do will reduce the size of the data. How we can be able to compress? See, data compression is nothing but representation of the data in the form of less number of bits. So that mean you are compressing the data. So that data compression performs the source coding. Okay, what is the need of source coding? In order to represent the data with fewer number of bits, or in order to reduce the size of the input data. So for example, if input is analog in nature and you are representing it in the form of zeros and ones, so automatically you are compressing the data. For example, if you can observe your mobile phone or like a laptop, what you are doing, so whatever the data that I am transmitting is stored in the form of ones and zeros, and at the receiver section you are able to listen my voice. Okay, so how we are transmitting? So we are not transmitting the continuous signal. We are first converting into digital by using the systems, and once again that is transmitted via the channel. Okay, that's here air, and at the receiver section at your home destinations you are going to listen that. Okay, where once again the digital data will be converted into analog format whenever you are listening via the speaker. Okay, so this is how we are going to I'm going to compress my data and transmitting to you. So like that, this is the main importance of source encoder. So source encoder represents the signal in the form of, or source information in the form of binary data. That's main intention is to reduce the size of the data. So a device that performs data compression is called as encoder. So what is this source encoder? Compress the data, or it represents the data with less number of bits. And also note that redundancy can be reduced, so that repetition of the data can be reduced. So redundancy can be reduced for effective representation at the output section. Okay, and this encoder performs data compression. Okay, and this compression may be either lossy or lossless. So for example, if some of the information is lost during transmission of the data, so I'm speaking to you, only half of the voice is audible to you and half is not audible to you, then some of the information is lost. So that is generally called as lossy compression. So lossless and no information is lost anywhere, whether it will be pictorial representation or voice, that's like audio or video or any image. So if no data is lost, no information is lost during the transmission, it is called, or during the compression, during encoding process, it is called as lossless compression. So this lossy or lossless compression can be related to either signals, or like audio or video signals, or it can be it can also be represented for image processing also. Okay, so compression can be for the signal, that may be audio or video, can be for the images. So meeru image processing in final year you will study, there you will read the process of image compression. So signal compression, and this is here we'll discuss the signal compression. Okay, so the advantage of source encoding is to reduce the bandwidth of transmission. So make exams lo, for example, if you are asked to write the advantages of source encoder, you need to write down all these points. Okay, so another advantage is to reduce the transmission bandwidth. Okay, next another like various kinds of techniques are there actually. Entropy based source encoding techniques like Shannon Fano coding method, okay, Huffman coding and run length encoding techniques, okay, can be able to improve the efficiency. Okay, these are generally the lossless compression techniques. All these Shannon Fano coding method, Huffman, run length encoding. So actually this is where this run length encoding is like a representation of a continuous, so same type of bits repeatedly. For example, like 0 or 1 is continuously repeated, then that will be represented, the data bit will be represented, and how many times it's repeated, the particular value will be represented instead of the corresponding bit so many times. Instead of representing a particular bit multiple number of times, that repetition value will be mentioned. Okay, so these please remember that these Shannon Fano coding method, Huffman, that two techniques that you are studying are comes under lossless compression techniques. These two comes under lossless compression techniques, and these, because these are based on entropy related source encoding. These are entropy based source encoding techniques. Because why I am specifying that entropy, because during this Shannon Fano coding method or Huffman coding method, the signal is transmitted based on entropy. So I think you know the definition for entropy, the number of bits incorporated in particular symbol or sample or an element. Okay, how many number of bits are grouped in a particular sample or symbol or message or any element. So that is entropy. So entropy based source encoding techniques examples are Shannon Fano and Huffman coding method, and run length also, but this has lot of drawbacks. Okay, even though it is simple, certain drawbacks are there in terms of efficiency. So Shannon Fano and Huffman are the best lossless compression techniques which relies on entropy based transmission. Okay, and another like decoder technique. So this encoder technique is used at the transmitter section, in the transmitter section prior to the channel encoder. So the main difference between channel encoder and source encoder, I specified in the first chapter also. So the main difference between source encoder and channel encoder is that in channel encoder, we'll add certain number of bits. Intentionally, we'll add some check bits in order to detect and correct the error bits. So like in channel encoder, the data size will increase. Data size will increase because we are adding certain number of check bits or interleaving in between the actual bits. Okay, that is channel encoder. So channel encoder lo what will happen, like some extra check bits will be added in channel encoder because our intention is to detect the error location where the error is there, and how can you be able to detect that error, detect and correct the error. Okay, so that things will be performed by the channel encoding system. And our source encoder technique, what it will do, it will reduce the size. Okay, this performs data compression. It reduces the size of the input data, input source information, so that redundancy can be reduced and data can be compressed and bandwidth can be reduced. But in the channel encoder is specifically used to detect and correct the error bits. That can be done by adding the extra bits. Okay, so in the known locations. Okay, that is the basic difference between source encoder and channel encoder. In the similar way, the opposite function we should be performed at the receiver section. So source decoder is added. First channel decoder will be added. It will be followed by source decoder. It converts the code format into source information. This will approximate like the replica of the input signal. Okay. So coming to the source coding techniques, there are two types of data compression. There are two types of data compression. As I already told you, the two are lossy compression and lossless compression techniques. So in the case of lossy, I told you that it will some sort of information will be lost during the compression, during the encoding. So lossy methods can provide high degrees of compression, okay, and result in smaller compressed files. But some number of original pixels, data or sound waves or video frames are removed forever. So how it will compress how the lossy source encoding techniques will compress the data by removing the some of the data. That can be, if it is image, some pixels will be removed, or some data can be removed, or in the some of the sound wave can also be eliminated, or in while video encoding, video frames can also be removed forever. So by removing some of the data based on the corresponding transmission while encoding process, these lossy methods can provide higher degrees of compression. Well and good. So compression rate is in lossy compression, but the information is lost. So efficiency will be reduced in the case of lossy compression. So lossy compression can provide higher compression rate, but with lesser efficiency because information is lost here. Next examples are the widely used JPEG. I think you know that JPEG image. Okay, so it can be able to compress with a lesser size. It's provided by discrete cosine transform. So we can compress it a lot, but what is the drawback here? The efficiency of the image gets reduced. So like image may get blur, or the clarity may gets missed here. So MPEG video compression. Okay, Alane, and this is for video compression, and MP3 audio compression formats. These are all the examples of lossy compression techniques. So the greater the compression, the smaller will be the file. But here, information will be lost, so efficiency in reproducing the signal gets disturbed here. But in the case of lossless compression, as I told you, the best example is zip file. So you are reducing the multiple. We are zipping multiple number of files in a single zip file. Okay, that can be used. That can be performed by using lossless compression. And some of the examples are also like run length encoding, Shannon Fano coding method, and Huffman coding method. We'll study about the Shannon Fano and Huffman coding method because in the case of Shannon Fano coding method, it is a one of the example of lossless compression method. But here we'll make use of cumulative distributive function in order to calculate the efficiency. And Huffman coding is more efficient and optimum over Shannon Fano coding method, because our Huffman coding method uses prefix free codes. See, prefix or prefix free, you can specify in any manner, no problem. You can pronounce as prefix or prefix free, mean that in a code generally we have multiple number of code words. Each code word, so no code word forms the prefix of the other code word. Okay, then it is called as prefix free code word. So best example is Huffman coding method. So this is the reason Huffman will have higher efficiency and optimum technique over Shannon Fano coding method. Anyhow, this is the introduction. We can go through directly into Shannon Fano and Huffman coding methods. So I will already I think I have started this. So I have directly I will tell you the steps to follow while calculating the efficiency in Shannon Fano coding method or the Shannon Fano encoding process directly by using the example. So in the exams, they may ask you to write down the steps to encode the input using Shannon Fano encoding method. So you can represent the step 1, step 2 and step 3. Or in some other textbooks, these 3 steps are divided into 4 to 5. But as my suggestion, these 3 steps are enough. Okay, because the repetition will the same process will continue. That thing I have directly mentioned in the step 3. And certain equations you need to remember. That's the efficiency calculation. Now, please, all of you remember this. Remember the 3 steps. And another thing is these problems are very, very important for your examination. So a certain number of probability values will be given to you, and you need to calculate the efficiency by using Shannon Fano encoding process. And you should know the encoding process, Shannon Fano encoding process, by using the 3 steps. So I have already started this encoding process. You can read this. So a discrete memoryless source have 5 symbols: x1, x2, x3, x4, x5 with the probabilities p of x1, p of x2, p of x3, p of x4 and p of x5. So how many symbols are there? So 5 symbols are there, and these symbols in some problems they may mention you like elements or messages, like the corresponding messages, like in any manner, whatever may be the element, you should accordingly you should represent in the table. If it's symbol and it's symbols and represent as that. If messages, write down it as messages. Whatever may be the element, like sample and samples rastar. Now, so 5 probabilities are given to you. How many probabilities are given to you? 5. Construct the Shannon Fano code for this source. Calculate the average code word length and coding efficiency of the source. So what you need to do? You are given with 5 probability values. You need to construct the encoding process using Shannon Fano code. Calculate the average code word length. This is represented with capital L. Code word length is represented as capital L with a variable capital L. And coding efficiency is represented with a variable eta. Please remember the particular terms, variable terms. Okay, the same terms I have used for Shannon Fano and Huffman coding methods. Okay, now here they have given you that m is equal to 2. What is m? So the number of bits in which you are fitting into one letter. How many bits are present in one particular letter? Group of letters. Okay, group of letters will be transmitted as a symbol. Group of letters will be transmitted as a symbol. Okay, now, so here you are given with 0 and 1 encoding bits for two partitioned subsets. Now please observe the steps given here. What is the first step? List the source symbols or messages in the order of non-increasing probability. So that's nothing but decreasing probability. So it should not be, it's not non-increasing probability, ante decreasing probability ani. So next, second step is partition the symbols or messages set into, so please divide or partition the corresponding set into two most equiprobable or approximately equiprobable subsets. Okay, so what you need to do, you need to divide the messages or symbols or any elements probabilities into two subsets. Why I am telling you the two subsets only? Because here M is given as 2 and you should assign 0 to the upper subset and 1 to the lower subset. Please remember that in the example, in the question, if it is given like M is equal to 3 and iste, then please divide the original set into 3 subsets and assign -1 to the first subset, 0 to the second subset and 1 to the last subset. Okay, but in general M will be given as 2. Okay, 3 iste em chestaru? -1, 0, 1. 3 subsets kinda divide chestaru and represent as -1, 0, 1 and okay, and assign like accordingly. So continue this process each time partitioning the sets with nearly equal probabilities as possible until further partitioning is not possible. So ఎంతవరకు ఇలా పార్టిషన్ చేస్తుంటారు? Until each subset contains only one symbol per message. One symbol or message. Okay, so until each subset contains only one symbol or message. Okay, now you can observe the Shannon Fano coding method. First ఏం చేస్తున్నారమ్మా? First you represent it as symbols x1, x2, x3, x4, x5. What is the probability? Please, what is the second column? In the second column you should represent the probabilities. How you need to like represent the probabilities in the non-increasing order, that is decreasing probabilities. So represent all the symbols in the decreasing probabilities or non-increasing probabilities. So you can see I have mentioned 0.4, 0.19, 0.16, 0.14, 0.11. Now, so this is the first step is over. What is the next step? So in the step 2, you can see that divide the initial symbols set, that is x1, x2, x3, x4, x5. Divide or partition into two subsets. Partition into two subsets such that the two subsets are equiprobable or approximately equiprobable and divide చేసిన వెంటనే ఏం చేయాలి? Assign 0 to the upper subset and 1 to the lower subset because M is given as 2 and partition value is given as 2. For example, if the partition value is 3 ఇచ్చారు అనుకోండి, అప్పుడు ఏం చేస్తారు? Divide these 5, a set consisting of 5 symbols into 3 subsets. ఎలా డివైడ్ చేయొచ్చమ్మా? ఇక్కడ 0.4 నెక్స్ట్ x2, x3 యాడ్ చేయొచ్చు, 0.19 plus 0.16 and x4, x5 యాడ్ చేస్తారు. Okay, so that -1, 0 and 1 will be assigned to x4, x5 and 0 will be assigned to x2, x3 and -1 will be assigned to x1 and once again x2, x3 will be partitioned, alane x4, x5 will be partitioned. Okay, మళ్ళీ ఇక్కడ మనకి x2, x3 partition చేసేటప్పుడు even though M is 3, -1, 0 will be assigned because there is no possibility of adding 1 anywhere. అలానే x4, x5 we have only 2 values. 3 values unte 3 values assign చేస్తారు. అదే మీకు x4 x5 సింబల్స్ ఉన్నాయి కాబట్టి assign -1 to the x4 and 0 to the x5. But in this example there is no issue. So directly they have given it as m as 2. So 2 ఇచ్చారు కాబట్టి assign 0 to the upper subset and 1 to the lower subset. And మళ్ళీ ఏం చేస్తారు? And this partitioning will continue till each subset consists of single symbol or single message. So here in the first subset we have 2 elements. So that 2 elements will be once again partitioned into x1 subset and x2 subset. In the x1 subset assign 0 and for the lower subset assign 1. If m is 3 ఏం చేస్తారు? -1 0 వేస్తారు అంతే. -1 for x1, for x2 it is 0. And 1 there is no place because no symbol is anywhere. Because that subset consists of only 2 elements. And here you have 3 elements. So x3, x4, x5. Now during partitioning, how can you partition? This is 0.16 and 0.14 plus 0.11. So ఎంత వస్తుందమ్మా మనకి 0.25. Okay, so you can partition as x3 as one subset and x4, x5 as another subset. So 0 is assigned to x3 and 1 is assigned to both x4 and x5. Next, if you observe the x1 subset, only 1 element, so you can stop the partition. And for x2 subset, only 1 element. And for x3, only 1 element. So alane x4, x5, but it has 2 elements, x4, x5 group ayi unnai. So dani malli partition cheyali. Please partition x4, x5 and assign 0 to the x4 and 1 to the x5. Okay, and now if you observe for the at partition 3, almost all the subsets consists of only one symbol. So that's why you can stop the partitions at during partition 3. Okay, you can stop dividing the subsets at partition 3 level. Now after completion of this, please mention the code word. What is the code word? So code word represents the number of zeros or ones present in the particular symbol, okay, during the partitions. So you can make, if you observe x1, please follow this row 1. So you have 0 0. So that's why I have mentioned the code word as 0 0. Next x2, observe the same row. So 0 1 and stop here. So what is the code word for x2? 0 and 1. What is the code word for x3? 1 0. So ade mention chesanu ikkada. Next, what is the code word for symbol x4? 1 1 0. So it is 1 1 0. What is the code word for x5? 1 1 1. So you can observe the code words for all the symbols accordingly by observing the corresponding row. Our row motto observe cheskondi chalu. So 0 0 0 1 1 0 1 1 0 and 1 1 1. Now what is code word length? So the units of code word length is generally bits. How many bits are there? That bit can be 0 or 1 or -1 also if m is 3. See, ఇప్పుడు మనకి m3 అనుకోండి, then -1 it will also act as one of the bit. -1 0 1, the 3. So don't consider the sign. Actually that sign refers that indication, that's not the negative sign. Okay, so general ga manam bit representation, if it is like 2 bits 0 1 and represent chesechu. So third bit add chesetappudu 2 అని పెడితే బాగోదు కాబట్టి -1 అని పెట్టారు. So those are the bits only, just for reference. Okay, so code word length represents the number of bits present for the particular symbol or present in the code word of the symbol code word. Now what is the length here? 0 0. And how many bits are there in x1 code word? 2. In x2 code word 2. x3 code word 1 0, so 2. So x4 code word 1 1 0, so it is 3. x5 code word 1 1 1 ante enamma 3. So accordingly, you will represent the code word length, and the units are bits, So this is how you need to represent the table even in the examinations. This is the process of Shannon Fano source encoding. So how you will encode it in the form of code words. So what is the code word for x1? 0, 0. What is the code word for x2? 0, 1. What is the code word for x3? 1, 0. What is the code word for x4? 1, 1, 0. What is the code word for x5? 111. Okay, like that we'll encode. Now, ikkadi varaku ardhamaindi kadamma. So this is how you need to represent the table for Shannon Fano encoding process. మీకు ఎక్కడి వరకు రావాలి? You need to represent the code word and its length. Okay. Now, see here, I will tell you an example. One point here. Here, if you observe x1 code word, it will start from 0 and second element is 0. For x2, the code word is 0 and 1. For x3, the code word is 1, 0. For x4, the code word is 1, 1, 0. For x5, the code word is 1, 1, 1. Now, if you observe x1 and x2 code words, please observe x1, x2 code words. Here x1 code word is first bit is 0 and second bit is 0. And x2 code word will also start with the same bit 0. But second bit will change, that is 1. So what it mean actually, here these are not prefix free codes. Because for x1 code word will also start with the same bit. Okay, so these the prefixes of x1, x2 are same. The prefixes for x1, x2 code words are same, or else sometimes the x2 code word will also start with 0, 0. Okay, so like that the prefix there is in Shannon Fano coding method, there is a possibility that the prefix of one code word is same as the prefix of other code word. So that is the main drawback of Shannon Fano coding method. If there is any error in one particular bit, for example, here you have divided and split as you have written as 0, 0. But instead of writing 0, 0, if you have written 1, 1, so there will be error, and the error will be, so x1 error, and even x2 will also get the same error. So error gets propagated. So what is the reason here? Even you can observe x3, x4, x5. Here if you observe the first bit, or you can say that LSB bit. Sorry, MSB bit avutundi kada. So this is MSB bit. The prefix bit of x3, x4, x5 all are same, and it is equal to 1. Okay, so because the prefix of one code word is same as the prefix of other code word, like error bits propagation, there is a chance of error gets propagated in the Shannon Fano coding method. So if everything is good, no issue, but sometimes if there is any error, that may get propagated whenever x3 like prefix of one code word is same as the prefix of other code word. This is the main drawback of Shannon Fano coding method. But in the case of Huffman coding, we don't partition. First thing is we don't partition, and we don't get the prefix of one code word as the prefix of other code word. There is a less possibility there. Okay, this is the Shannon Fano coding method. The table you should remember. And now what parameters you need to calculate from the table? Average code word length, capital L, it is represented with a variable capital L. Entropy, source entropy, capital H. And efficiency is represented as capital like eta. Okay, so average code word length. So what is the definition for average code word length? So it is the product of, or you can say the average of all the elements, and the product of the probability of The probability and the length of the particular message. Okay, the probability multiplied by length of the particular message. Okay, and all the 5 values you need to consider. So the in terms of equation, you can represent it as summation k is equal to 1 to 5 pk, that is the probability of the kth message or kth symbol multiplied by the corresponding length of the code word. Okay, so what is the probability of the first message? First symbol ki probability entamma? For the symbol x1, so average code word length is up, you can obtain the average code word length by taking the sum of product of probability and code word length of all symbols. So ఎలా వస్తుందంటే for x1 it will be 0.4 multiplied by 2 plus for x2 0.19 multiplied by 2. So probability of first message multiplied by code word length of first message or first symbol, and second plus probability of second symbol multiplied by code word length of second symbol, and third plus 0.16 multiplied by 2 plus 0.14 multiplied by 3 plus 0.11 multiplied by 3. So like this you can calculate the average code word length. So total code word length can be obtained by taking the sum of products of the probabilities and code word lengths of all symbols. That can be represented in the form of equation as summation k is equal to 1 to 5 symbols, because 5 symbols, p suffix k into L suffix k. L suffix k represents the code word length of the kth message or kth symbol. P suffix k represents the probability of kth symbol. Okay, any symbols unte a corresponding probability multiplied by code word length and take the sum. So you can see summation k is equal to 1 to 5 p suffix k multiplied by length of the corresponding message in bits. Okay, so the length, I told you that the units of length are bits. Okay, now so finally you obtain the 2.25 letters per symbol. So the units of average code word length is letters per symbol. How many number of letters are present in symbol? Okay, now next calculate the entropy. So how can you calculate the entropy? Entropy, I think you know the definition for entropy. So summation, here I took the variable as k. So summation k is equal to 1 to 5 p suffix k log 1 by p suffix k base 2. So h is summation k is equal to 1 to 5 p suffix k log 1 by p suffix k base 2. Okay, so ikkada just a probability matram తీసుకుంటారు. So for calculation of entropy, I think you know that probability matrix is enough. అది కూడా ఇక్కడ ఏ probability calculate చేస్తున్నారు? Marginal probability. So probability of the transmitter section. So h is summation k is equal to 1 to 5 pk log 1 by pk base 2. So p suffix k is 0.4 for the first symbol, 0.4 log 1 by 0.4 base 2 plus 0.19 log 1 by 0.19 base 2 plus 0.16 log 1 by 0.16 base 2 plus 0.14 log 1 by 0.14 base 2 plus last one 0.11 log 1 by 0.11 base 2. So it is equal to 2.15 bits per symbol. So this is how you will calculate the average code word length and entropy. So the units are entropy are bits per the corresponding element. Here the elements are symbols. So bits per symbol. So efficiency. So how you can, so please remember these expressions. Code word length, entropy you can remember because already you studied. Code efficiency eta. So code efficiency eta is defined as ratio of h of x divided by L into the product of average code word length multiplied by log m base 2. Here log m base 2 represents the maximum entropy. So maximum entropy under equiprobable condition. Okay, that's the rare condition. Here m is given as 2. So log 2 base 2 1 will be 1. So there is no need of considering this. So but in some textbooks it will be given, the efficiency expression will be directly given as h of x by L. But it's not so. H of x divided by L into log m base 2, because m value is 2. And మీరు partition చేసేటప్పుడు you have assigned 0 to the higher subset and 1 to the lower subset, and you have divided into 2 partitions. అదే మీరు 3 partitions కింద divide చేయాలి if m is 3 అంటే. Okay, so h of x divided by L into log m base 2 bits per letter into 100. So what is h of x? H of x is entropy, that is 2.15 bits per symbol, divided by average length is 2.25 letters per symbol. So 2.25 letters per symbol into log 2 base 2 bits per letter. So letters gets cancelled. So denominator you will get bits per symbol, and numerator entropy units are bits per symbol. So code efficiency has no units. So multiplied by 100 gives you the average, the efficiency in terms of percentage. So that is 95.5%. So this is how you need to calculate the efficiency for using Shannon Fano encoding process. Okay. Now it will be more clear if you check the second example. Please check the second example which I will show you. So you can see the second example. Find the Shannon Fano code from the given values below and calculate the coding efficiency. So in order to, they will ask you to calculate the coding efficiency, but in order to calculate the coding efficiency, you should know the average code word length. You should know the average code word length. Alane entropy and m value, log m base 2. So directly you can substitute the value of m. Okay, and consider the table with 8 probable messages m1, m2, m3 up to so on m8 with corresponding probabilities. So you can observe the table m1, m2, m3, m4, m5, m6, m7, m8. Now this you need to construct in the form of table for Shannon Fano source encoding process. So that table consists of, first column is messages, second column probabilities, third column partition 1, third column ela vachindi meeku partition 1, fourth column partition 2, partition 3. This process will continue till each subset consists of only one symbol, and code word, last code word length. Okay, like that you need to represent the table. Now I request any one of the student to, already I told you the process. Please tell me the 3 steps used for Shannon Fano encoding process. Any one of the student. What is the first step? What is the first step? I request any one of the student to please tell me the process of Shannon Fano encoding process and tell me the expressions. Okay, Punyavati unnarma J4. J4. L9. L9. M0. M0. Ma. M0. Lateral entry 22. So meanwhile, other students can take the probabilities and start doing the process. So first probability is 0.5, second probability is 0.125. First, whenever M1 is like in the form of ratios, so get the value, divide 1 by 2, so you will get 0.5. Write down the corresponding values, so that it will be easy which one is higher and which one is lower. So what is the first step in Shannon Fano encoding process? Okay, ma. N4, Padma.
Ma'am.
Okay, cheppandi ma. What are the 3 steps in Shannon Fano encoding process? What is the first step?
List the symbol probabilities in decreasing order, ma'am.
Okay, first step. Next step is?
Partition those probabilities into 2 sets which are equiprobable.
Equiprobable or approximately equiprobable.
Equiprobable.
So two sets ena, 3 sets kinda divide cheyakuda?
Cheyach, ma'am.
If M is 3.
3.
Okay, so partition the set into M number of subsets anandi. Appudu baaguntundi. Okay, so actually if M is 2 sets. If M is 3 subsets kinda divide chestar. Okay, next.
Okay. Assign 0 to upper set and 1 to lower set. If M is 3, then assign -1, 0 and 1.
-1, 0, 1. So for example, if the subset consists of only 2 bits, appudu manam M is equal to 3 iste, then assign -1 to the upper subset, 0 to the lower subset.
0 to lower subset.
Inka 1 leave chesestar. Okay ma, next.
Continue the process until further partitioning is not possible.
Okay. Till each subset consists of only one symbol or message. Okay. So ikkada ela divide chestaru? Can you so chudandi ikkada? Can you see the slide?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay ma, చూడండి చెప్పండి ఒకసారి ప్రాసెస్ చెప్పండి. What you understood?
ఫస్ట్ ఈక్విప్రాబబుల్ లో చేయాలి కాబట్టి చూసుకోవాలి మేము 0.5 విడిగా పార్టీషన్ చేసి మిగిలినవన్నీ ఒకసారి ప్లస్ చేసుకొని చూసుకుంటే కొంచెం క్లోజ్ టు 0.5 ఉంటే అవన్నీ విడిగా పార్టీషన్ చేసుకుంటాం మేము.
ఓకే అమ్మా. సో ఫస్ట్ అప్పర్ సెట్ కి చెప్పండి.
0 నెక్స్ట్ లోవర్ సెట్ కి 1 ఇచ్చుకుంటాం మేము.
1 పెట్టేశారు. ఓకే, ఫర్ ఆల్ M2 to M8 ఇవన్నీ యాడ్ చేస్తే మీకు 0.5 వచ్చింది. సో యూ కెన్ అసైన్ 1 to all subsets M2 to M8. ఓకే, నెక్స్ట్.
ఫస్ట్ దానికి పార్టీషన్ అక్కడ ఆపేయచ్చు మ్యామ్, ఒకటే ఉంది కాబట్టి.
ఓకే.
సో నెక్స్ట్ 0.125 ప్లస్ 0.125
చెక్ చేసుకుంటారు. చెక్ చేసుకుంటే 0.25 వస్తుంది. అండ్ ఇఫ్ యూ యాడ్ 0.625 ఆల్ అలానే 0 ప్లస్ 0.3125 M4 to M8 యాడ్ చేస్తే మీకు 0.25 వస్తుంది. సో అసైన్డ్ 0 to the M2 and M3 and assigned 1 to M4 to M8. ఓకే, నెక్స్ట్
M2 M3 0 ఉన్నాయి కాబట్టి అందులో పైన 0 ఒకటి, కింద దానికి 1 ఇచ్చేస్తాం.
పార్టీషన్ చేస్తారు. నెక్స్ట్ పార్టీషన్ ఈస్ దేర్. ఓకే. Okay, next.
Similarly, for M4 and M5, we add those probabilities 0.0625 and 0.0625.
So you will get 0.125.
Yes, ma'am. That is approximately equal to probabilities of M6, M7 and M8.
Okay. So assign 0 to M4, M5.
And 1 to M6, M7 and M8.
Okay, good.
For M4 and M5, partition is there, and assign 0 to M4 and 1 to M5.
Okay.
Further partition is not possible for M4 and M5.
Yes.
And for M6, 0.625 is approximately equal to the probabilities of M7 and M8. So assign 0 to M6 and assign 1 to M7 and M8.
Okay.
Next, further partition is not possible for M6 and assign 0 to M7 and 1 to M8.
Now, okay, ikkada varaku chesaru. So now my question is here, actually you have partitioned this into 0.625, 0.1325 and 3125. So illa partition చేసేటప్పుడు some students may do partition as 0.625 plus 0.3125 they have considered as one subset, and 0.3125 as another subset కింద చేశారు అనుకోండి, for example. Okay, then the efficiency will change. Say yes or no. Efficiency change అవుతుందా అవ్వదా? అంటే ఇప్పుడు ఇక్కడ యాక్చువల్గా ఇక్కడ పార్టిషన్ చేసుకునే ఆర్ఎల్స్ ఇనిషియల్ పార్టిషనే చూసుకుందాం. ఫర్ ఎగ్జాంపుల్ ఇన్స్టెడ్ ఆఫ్ 0.5 ఇక్కడ 0.6 ఉంది అనుకోండి, ఆర్ 0.4 ఉంది. అప్పుడు you will partition M1 as one subset and M2 to M8 as another subset. You did like that. Another student, yes, they may partition as M1, M2 as one subset and M3 to M8 as another subset. Not like student. Okay, so during the encoding process there are like more number of partitioning ways, possibilities. Ante kada? So there, okay, this is the main drawback of Shannon Fano encoding process. So there are more ways of partitioning, because in equiprobable there is no issue. Perfect ga meeku equiprobable undi ikkada actual ga 0.5 for the upper subset and M2 to M8 it is 0.5. So here there is no issue. Ante perfect ga meeku equiprobable undi. But in some other examples there is a possibility that the division may not be exactly equiprobable. Ante approximately equiprobable unnappudu there are multiple ways of partitioning steps. So then there is a change of shuffling efficiency. So the efficiency of Shannon Fano coding method is not stable. Okay, so ivanni drawbacks lo cheppali, but encoding process meeku teliyali kabatti you can solve. Okay, so ee example lo meeku problem em ledu. So M1 you can partition and M2 to M8 you can take as another subset. Is it okay?
Yes, ma'am.
Okay, whatever I said is clear to you?
Yes, ma'am.
Okay, next what so you will do partitioning till each subset consists of only one message. What next?
Write the code word, ma'am.
Write the code word for all the messages. Okay. For M1 what is the code word? Please observe the row.
Yes, ma'am. For M1 0 and for the M2 code word is 100 and for M3 101, for M4 1100, for M5 1101.
M5 ఎంతమ్మా?
1101.
1101. Okay. Next M6
For M6 1110.
0. Okay. M7
For M7 11110.
4 ones 0. Okay. Next M8
For M8 11111.
5 ones. Okay, good. Next code
Next
word length. What is the code word length for M1?
M1 1.
M2 3 bits ఉన్నాయి. So 3. M3
For M3 3.
M4 how many bits are there?
For M5 4. For M6 also 4. For M7 5. For M8 also 5.
Okay. Like that you will calculate the code word length and the units for the code word length are bits. Okay. So ఇక్కడ మీరు కాలమ్స్ అని పెట్టుకోవచ్చు లేదంటే పార్టీషన్స్ అని పెట్టుకోవచ్చు వాట్ ఎవర్ యువర్ విష్. ఓకే. బట్ లాస్ట్ కాలమ్ షుడ్ బి కోడ్ వర్డ్ లెంత్ అండ్ least but one column should be code word. First column should be message or symbols, whatever the elements given to you, and second column should be probabilities, and these probabilities and messages should be represented in the non-increasing probabilities or decreasing probabilities. Okay, next what is the next step? Next ఏం చేస్తారమ్మా?
Average code word length find out.
Average దానికి ఈక్వేషన్ చెప్పండి.
L is equals to summation 1 k equals to 1 to 8 pk into length of corresponding code word.
Very good. So ఇక్కడ ఎలా రాస్తారా ఈక్వేషన్? 0.5 into
0.5 into 1 plus 0.125 into 3 plus 0.125 into 3 plus 0.0625 into 4 plus 0.0625 into 4 plus 0.0625 into 4 plus 0.03125 into 5 plus 0.3125 into 5.
వెరీ గుడ్. ఓకే, నెక్స్ట్ అది అయిపోతుంది, క్యాలిక్యులేట్ చేస్తారు. వాట్ ఆర్ ద యూనిట్స్ ఫర్ ఎల్ లెంత్? యావరేజ్ కోడ్ వర్డ్ లెంత్ కి యూనిట్స్ ఏంటి? బిట్స్ పర్
ఓన్లీ.
ఓకే. నెక్స్ట్ ఏంటి క్యాలిక్యులేట్ చేస్తారు? ఎంట్రోపీ క్యాలిక్యులేట్ చేస్తారు. వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ ఎంట్రోపీ?
H is equals to summation k equals to 1 to 8 pk log 1 by pk base 2.
ఓకే, డైరెక్ట్ గా సాల్వ్ చేస్తారు. వాట్ ఈస్ ద ఎక్స్ప్రెషన్ ఫర్ కోడ్ ఎఫిషియన్సీ?
H of x by L into log m base 2 into
H of x by L into log m base 2. In this case, what is m?
2 mem.
So log 2 base 2 will be
1.
So the expression for efficiency will be h of x by capital L, where L units are letters per message. This is the unit for average code word length because you are considering all the messages. Okay. Next, like maximum entropy units are bits per letter, and information per message will be bits per message. Okay. So accordingly, you can see the units in this slide. Next. Okay, you can calculate the average code word length. ఒకసారి calculate చేయండి, చేసి ఆన్సర్ చెప్పండి. Is it 2.3125 letters per message? Please check this and tell me. You take time, no problem. Okay, please multiply the probability, the corresponding message probability and the code word length, and add this for all the k messages. Tell me whether it is 2.3125 letters per message or not. ఒకసారి చెక్ చేయండి. So and the same way tell me the entropy is 2.3125. సేమ్ వాల్యూ వస్తుంది ఈ ఎగ్జాంపుల్లో. ఒకసారి చెక్ చేయండి అమ్మా, ఇది చెక్ చేసి ఆన్సర్స్ చెక్ చేసి వాట్ ఈస్ ద ఎఫిషియన్సీ ఫర్ దిస్ సోర్స్ ఎన్కోడింగ్ ప్రాసెస్. ప్లీజ్ చెక్ దిస్. So what is the coding efficiency for this Shannon Fano encoding process for this example? Did you get it as 100%? I request all the other students to please solve the same example. Why all others are not responding whenever I call your number? Poni intentional ga respond avvatledu. At least whenever I call your roll number, at least you should say yes or no, whether you are interested to tell or not. Why you students are not responding? చెప్పండి మా సేమ్ వాల్యూ వచ్చిందా? L 2.3125 letters per message and H 2.3125 bits per message.
Yes, ma'am.
Efficiency 100% వచ్చిందా మీకు?
Yes, ma'am.
Okay, very good. So finally, this is the process of doing the Shannon Fano encoding process. Okay, Ma, thank you. You can mute yourself. Okay, you can see another example which I will post you this PDF. Okay, so this is like offline, where during the physical classes I used to give so many examples, but in this PPT I can show you only few, and I will post this PDF which I have discussed with your seniors. Okay, you can see all these examples today or tomorrow I will post, because once I complete this PPT I will post. So this is the same example, I think. Okay, okay, then I request the students to take the same example. At the first example చెప్పాను కదమ్మా, please consider the same example and try to calculate the efficiency. ఒకసారి చూడండి, listen to my question carefully. Take the same example, that small example I will give you. Okay, so consisting of only 5 elements. Take the same example, please take the same example, and instead of taking m is equal to 2, please take m is equal to 3 and calculate the efficiency. Take that as homework. So what's your homework? Take p of x1 as 0.4, p of x2 as 0.19, p of x3 as 0.16, p of x4 as 0.14, and p of x5 as 0.11. Okay, these are the 5 symbol probabilities given to you. Now construct the Shannon Fano code table for these source elements and calculate the average code word length and coding efficiency. So ante entropy kuda calculate chesukovali, because until and unless you don't know the entropy, you cannot calculate the coding efficiency. Here m is equal to 3 bits per letter, it's given like that. So meeku what is the expression for code efficiency then? H of x divided by L into log m base 2, ante log 3 base 2 you will get. Okay, so take that as homework and please tell me what is the efficiency. Is there any change in the efficiency, or is there any increase or decrease? What happens to Shannon Fano encoding process as and when the m value increases? Okay, so as and when the grouping of bits per letter, if m value increases, what will happen to the efficiency of Shannon Fano encoding process? Take the first example and take m is equal to 2 and calculate the efficiency. Now here please all of you observe this slide shown here. The advantages of Shannon Fano encoding process. In the Shannon Fano coding procedure, we do not need to build the entire code book. Instead, we simply obtain the code for the tag corresponding to the given sequence. So it is entirely feasible to code sequenced of length 20 or much more. Okay, the process of doing or generating the code words, they are telling that the process is like based on the probability division. Okay, so like it's feasible to a length of 20 and something much more. Okay, that is the advantage because it is completely based on subset division. But this Shannon Fano coding method has lot of drawbacks. Okay, so those drawbacks include, listen this drawbacks of Shannon Fano encoding process. First one is there is ambiguity in Shannon Fano coding process due to the availability of multiple ways of partitioning. Here there is an ambiguity in Shannon Fano coding method due to the availability of multiple ways of partitioning. So how many partitioning ways are there? Multiple ways. As I told you, in the case of equiprobable there is no issue, but in the case of approximately equiprobable there are multiple ways of partitioning the set into subsets. So that's the reason that efficiency of this method is not stable. Okay. For example, if the upper subset and the lower subset are not exactly equiprobable, then there are two ways of like partitioning. So then the efficiency of the method is not stable. That is the first drawback. And the second drawback is here there is an ambiguity in Shannon Fano coding process due to the availability of multiple ways of partitioning. Therefore, the efficiency of this method is not stable. So second drawback is here we have no unique code. No unique code. So what it means? So actually I told you during the process, if you see the block once again, if you observe the codes in this example, if you observe the codes, the first code word is 0, second code word is 100, and third code word is 101, fourth is 110, fifth is 1101. Now if you please observe M2, M3, the first two MSB bits are 10 only. And for M4 and M5, 110, 110. So for M6, M7, first 3 bits are 111. And for M8 and M7, first 4 bits are 4 ones followed by 0 or 1. Like this, the code words are not unique. Okay, these if you observe M7 and M8, the first 4 bits are common to M7 and M8. So like that, in this Shannon Fano coding method, the prefix of one code word will be the prefix of another code word. So that's the main drawback. And here there is no unique code word. Almost all the MSB bits are like similar only. That is, a code might be prefix of another code. So in case of errors or loss during data transmission, we have to start from the beginning. So what is the drawback here? Here we don't have any unique code. That is, the code word may be prefixed for the same code may be prefixed for 2 to 3 subsets. So in case of errors or any losses, we have to start from the beginning onwards. Okay, that is another drawback. And third drawback is Shannon Fano coding method does not guarantee optimal codes. Does not guarantee optimal codes and does not achieve lowest possible expected code word length. Why L should be low? Because if you observe the equation efficiency, code efficiency eta is h of x divided by L into log m base 2. So in the denominator you have code word length, average code word length capital L. So the lower the value of code word length, higher will be the efficiency. Or at least this should be equal to the entropy. Okay. So the lower the value of expected code word length, higher will be the efficiency. So that's why Shannon Fano coding method, in Shannon Fano coding method, there is the least possible value of getting the lower value of expected code word length because it uses cumulative distributive function. This produces low efficiency. This is not a prefix free code, so that's why, and it uses cumulative distributive function. So this produces the low efficiency, and even that efficiency is not stable because of multiple ways of partitioning. As m tends to increase, this method is not suitable because I have given you as homework. Take the first example and try to solve the same by using m is equal to 3 bits per letter. Okay, tomorrow all of the students who are present in the classroom, please try to solve that problem and get me the efficiency by considering the m as 3 bits per letter. Use Shannon Fano encoding process and calculate the efficiency. Then you will be more clear about the last drawback of Shannon Fano coding method. Okay, this is all about the Shannon Fano encoding process. I think you are clear now. You can take any one of the example and you can first you represent all the messages in the decreasing order, and next partition into equiprobable or partition the first set into equiprobable or approximately equiprobable subsets, and this and assign if m is 2, assign 0 to the upper subset and 1 to the lower subset. For example, if m is 3, you have to divide it into 3 subsets and assign -1 to the upper subset, 0 to the middle subset and 1 to the last subset. And continue this process till each subset consists of only one message or symbol. Okay, this is the process. The same process will continue for all the techniques. So whenever question is given to you in the exams, you should represent the Shannon Fano coding table మొత్తం draw చేయాలి. And second thing is you should know the expressions. Please you should write in the exam and you can get the efficiency. So in this type of questions gives score, you can score good marks because the examiner has no chance to decrease the marks because nothing is there except the table and the 3 steps and followed by the equations rase values pedte saripotundi. So you will get if it is 8 marks, you will get complete marks. Next, let us go through the Huffman coding. So whatever the drawbacks you observed in the Shannon Fano coding method, almost all we can overcome by using this Huffman coding method. Okay. So if you remember the drawbacks of Shannon Fano, you can write down the advantages of Huffman coding method. And another advantage common advantage for source Shannon Fano and Huffman coding is both relies on entropy based source encoding and both are lossless. So the two are the advantages, common advantages for source and Shannon Fano and Huffman coding. What are the common advantages? Both are lossless compression techniques. Second one is both the techniques uses entropy based source encoding. Okay. So coming to the Huffman coding, this produces high efficiency, and this encoding process is optimum when compared to Shannon Fano coding process because it uses prefix codes. So please remember one point here. Prefix sometimes you can also call it as prefix free. Prefix nothing but prefix free ani. And prefix free undi kada, ikkada prefix undi kada, but both are same. In the prefix codes, the prefix of one code word is not equal to the other code word, to the prefix of other code word. Okay, so Huffman coding is highly efficient and optimum technique over Shannon Fano coding method because it uses the prefix free codes or prefix codes. In prefix code, no code word forms the prefix of other code word. The prefixes of all the code words is not same, or no code word forms the prefix of other code word. Ante akkada partitioning anedi jaragadu. That's the first advantage. Second advantage is there is no ambiguity in Huffman coding method as the last two terms or last three terms based on the value of m are combined. Just ఇక్కడ యాడ్ చేస్తుంటారు అంతే, లాస్ట్ టూ టర్మ్స్ ని యాడ్ చేస్తుంటారు. ఫస్ట్ స్టెప్ ఫర్ షానన్ ఫానో కోడింగ్ మెథడ్ అండ్ హఫ్మన్ కోడింగ్ మెథడ్ ఈస్ సేమ్. What is the first step? Represent the messages or symbols in the decreasing order probabilities, in the non-increasing order probabilities or decreasing order probabilities. The first step for Shannon Fano coding method and Huffman coding method is same, and second step will change. So here in the Huffman coding method, we don't have any partitioning of sets into subsets, into m number of subsets, as what we did in the Shannon Fano coding method. Here we don't partition the sets into subsets. What we'll do here, we'll add last m terms. For example, if m is 2, last two terms will be added. If m is 3, last three terms will be added, and we'll assign 0 or 1, 0 and 1, 0 to the last but one term and 1 to the last term. If m is 3, we'll assign -1 to the last but second term, and 0 to the last but one term and 1 to the last term. Like that we'll assign, and just this is like combining the last three terms, last two terms or last m terms, and the reduction process will continue till m number of messages remain in the reduction. How many number of messages? M. For example, if m is 2, this process will continue till 2 bits are present. Okay, and last lo a 2 terms ni kuda add chesesi we'll assign 0 to the higher bit and 1 to the last bit. Okay, like that we'll combine, and you will get the total sum of all the probabilities as 1. So this efficiency of this method is stable. So anyhow, we'll discuss the process, but the thing here is there is no ambiguity in Huffman coding, because here we don't have any partitioning procedure. Here we'll combine the last m terms as a reduction process. It's a reduction process, and because we'll combine the last m terms. Okay, ma? So these are the two advantages. Next, followed by, here we have unique code, because this is not at all the partitioning process. This is a reduction process or combining process, which is called as a reduction process. So reduction process based on combining the last m terms. Here we have unique code, that is, a code will not be a prefix for another code. So no code word will be the prefix of other code word. So the unique code here we have, even when there exists any error or any loss during data transmission, we can consider only the corresponding reduction. Okay, because no code word will be the prefix of another code word. Here that is no code word will be a prefix for the another code word. Even when there exists any error or any loss during the data transmission, we can consider only the corresponding reduction term. Okay. And Huffman coding can guarantee optimal codes, because by using this Huffman coding method, we can achieve lowest possible average code word length. So L, you can reduce the value by using Huffman coding method, because in order to improve the efficiency, the length should be, average coding length you need to minimize. Minimize ante 0 chesekuddu, but you need to minimize. If so, we can improve the efficiency, because in the code efficiency expression you can see it is h of x by L into log m base 2. So our efficiency is inversely proportional to the length. Okay, Because it uses prefix-free codes, we can say that the L is minimum. So in this, we can guarantee optimal code and good efficiency by using Huffman coding method. Okay, as M tends to increase, the reduction process will last with a low span of time. That is the advantage for Huffman coding. So almost all 5 advantages, 5 plus 2 advantages. Common advantages ఏంటంటే ఇక్కడ? So this is lossless compression. So lossless compression, comma, entropy based source encoding okay, these are the common advantages. So I can write the same common advantages in Shannon Fano coding method also. Okay. These two are the common advantages for both the techniques. Ambiguity. Okay, total of 7 advantages are there for Huffman coding method because it follows lossless compression technique. Okay, these are the advantages of Huffman coding method over Shannon Fano encoding process. Okay, so these are the advantages. Here, these first two are the common advantages for Shannon Fano and Huffman coding method. So both techniques follows lossless compression and entropy based source encoding process. So that's the 2 advantages for Shannon Fano and Huffman, and the rest 5 are the specific advantages of Huffman over Shannon Fano coding method. Now we can go through the example. Okay, so I will show it in the Word document. Later I will dump in the PPT because in the PPT I cannot show like continuously because per slide I can post only like a small amount of content. So if it is like Word, if I type it in the Word, it will be more comfortable even for you students to check simultaneously. ఒక slide నుంచి ఇంకో slide కి వెళ్ళే లోపు sometimes there will be like issue. Now please take the example. Please observe the example. A discrete memoryless source. This is based on Huffman coding. A discrete memoryless source has an alphabet of 7 symbols with probabilities for its output as described in the table. In the table, they have given you the 7 symbols and their 7 probabilities and their respective probabilities. Take m is equal to 2 bits per letter. So consider 0 and 1 encoding bits. Consider 0 and 1. ఇక్కడ ఏం రాస్తారంటే పార్టిషనింగ్ అనొద్దు, 0 and 1 during a reduction process, right? Reduction process. We'll call it as a reduction process, not the partitioning process. Ikkada partition cheyaru. Will reduce by combining. Will reduce the total number of bits per letter upon combining the last m number of terms. Okay. So this is the question given to you, and you are supposed to calculate the efficiency. Okay, you are supposed to calculate the efficiency, and also remember that same expressions will be used here because this is a lossless, both are lossless and entropy based like source encoding process. Both the Shannon Fano and Huffman coding method, the efficiency equations, alane the code word length equations, all are same. All are same. Now here symbols are represented as S0, S1, S2, S5. So that's given in the question. So directly you take the value. Are they M1, M2, M3, M4 up to M7 is the take the corresponding values. So whatever the variables given, you used the same variables. So symbol S0, S1, S2, S3, S4, S5 and S6. Now you are supposed to calculate the Huffman code. So you are given with 0.25, 0.25, 0.125, 0.125, 0.125, 0.625 and 0.0625. So before starting the source encoding process, first of all add all the probability values and check that whether it is equal to 1 or not. Adi check cheyalసిన responsibility meede. So adi mistake ani munduga meer telusukopothe it will be like lot of time you will get waste. So 0.625 plus 0.625, that is 0.125 plus 125, that is 0.25 plus 0.125, 0.15, that is 0.2525. So this is 0.5 and 0.25 plus 0.25, it is 0.5. So total it is okay, no issue here. So 0.5 plus 0.5, that is 1. So now you can move to the table. So here in the table, first what is the first step? First step is common for both the source encoding and Huffman coding process. Symbol is first represent all the symbols. And before representing the symbols, first please check whether the probabilities are in the decreasing order or not. The order of representing the symbols or with like non-increasing probabilities or decreasing probabilities. Here please check. All are in the decreasing probabilities only, because in the question itself they have given like the order in the decreasing probabilities or the symbols in the order of decreasing probabilities. So directly you can write it, no issue. Okay. So please check this. So here we have symbol S0, S1, S2, S3 up to so on S6. Now in the first step, what we'll do? Please represent the probabilities in the decreasing order. So 0.25, 0.25, 0.125, same values we mentioned. Now, so what we'll do in the stage 1? So in the stage 1, last m number of bits are combined, but in the question it is given last 2 bits because m is given as 2 in the question. So here last 2 bits are combined. So 0, 1. They are combined. Combine chesi em chestaru? Next represent the corresponding added value. So here 0.625 plus 0.0625. That will be how much? 0.125. Please combine the last 2 terms. Last m terms should be combined. Here m is 2. So last 2 terms will combine and assign 0 to the last but 1 term and 1 to the last term. Assign 0 to the last but 1 term and 1 to the last term. Assign. First add and assign. Then you will get 0.125. Okay. Now please relocate the value, the added value. in the order of decreasing probabilities. In the order of decreasing probabilities. So 0.25, 0.25, what is the added value? 0.125. So relocate this into the new position in the stage 2 by in the order of decreasing probabilities. So our S2, S3, S4 positions will change. Okay, so because this is 0.125. Next, once again, last two terms are combined. So in the stage 2 also, like in the combining process, last two terms are combined. So we are combining and assigning and relocating the probability value so that the reduction process will continue. So last two terms will be combined and assign 0 to the last but one term and 1 to the last term. If these two are combined, you will get 0.25. Take that value to the highest position. So if you have similar values, take that to the highest position and write down the order of decreasing probabilities. And every time while writing the order, please observe the locations of probabilities of each and every symbol carefully. So if last two terms ni add cheste, you will get 0.25. So take that 0.25 to the highest position if you have 0.25s. If you don't have 0.25, no matter, you can directly take it. So మీకు ఇంకా 0.25 సేమ్ వాల్యూస్ ఉన్నా కూడా దీన్ని హైయెస్ట్ పొజిషన్ కి తీసుకువెళ్ళాలి. Okay, so add like this and assign 0 and 1 and take that to the highest position. Okay, and now this S0, S1 positions will change. So please represent with the arrow that way, like the relocation of S0, S1. Just down corresponding values. Next, once again, last two bits are added. 0.125 plus 0.125 and assign 0 to the last but one term and 1 to the last term. Okay, and 1 to the last term. Okay, so what we did? Okay, 0.125 plus 0.125, it will be 0.25. So assign 0 and 1 and relocate that to the highest position in the order of decreasing probabilities or non-increasing probabilities. Mali 0.25, 0.25, 0.25 and 0.25. Once again, last two bits are added. So you will get 0.5. So take that to the highest position. So don't take every time that to the highest position. So similar values unte highest position ki తీసుకువెళ్తారు or else obviously the highest position. So 0.5 is greater than 0.25 and 0.25. So it will be the highest value because in all the stages you need to represent the probabilities in the decreasing order. So 0.5, 0.25, 0.25. Next, once again, add the last two bits. So 0.25 plus 0.25, that is 0.5. So here we have once again 0.5, but the newly added value will be considered as considered in the top position. So 0.5 and the earlier 0.5 will goes to the lower position. So 0.5. So the reduction process is completed up to here, but at last once again you will combine these two to generate the total probability as 1. There you assign 0 and 1 to the last but one term and 1 to the last term. Please listen carefully the process. So what is the first step? First step is represent all the probabilities for the symbols in the decreasing order or non-increasing order. Anni represent chesaka, then combine the last m number of terms. Here m is 2, so combine last two terms. Last two terms add cheste, what are the last two terms? 0.0625 and 0.0625. So assign 0 and 1. Next. So it is 0.125. Next, please relocate the value of newly or combined term. Combined term will be 0.125. Already we have 0.125s. but the position should be, but this newly added term will goes to the top position. Even we have similar values. So our S2, S3, S4 values positions will change. So please mention with the arrows. Okay. Next, once again, in the stage 2, add last two terms or combine the last two terms, and the newly added value will be 0.25. So it is added in the highest position or in the top position if you have similar terms. If we have no similar terms and the value is highest, no matter, directly we can take the highest position. So same values unna kuda, but this newly added term will goes to the top position even if values. Next, once again, last two terms you will add and assign 0 to the last but one term and 1 to the last term. Like that, the positions will change and last two terms will combine, assign 0 and 1 and change the position based on the non-increasing order. If we have similar probabilities, then also take that to the top position. So, in case lo chudandi meeru 0.25, 0.25, the value is 0.5, both are same, but take the newly added term to the top position. Like that, in the last stage, if you observe stage 6, 0.5 and 0.5. So the reduction process you will continue till m number of terms remain and cheppam. That is the last step. The reduction process will continue till the last m number of terms remain. So 0.5, 0.5. Please add 0 to the highest bit and 1 to the lowest message. Okay, this is how you will represent the table. Now you will get the path for S0 code word. So next thing is representation of code word. Actually, ikkade malli inko table ke add cheseskondi meer code word and its length. So observe the path of S0. What is the path of S0 in the reverse direction? Observe the path of the corresponding symbol in the reverse direction. So అందుకనే మీరు ఇక్కడ path mention చేసుకోవాలి. What is the relocation of S0? ఇక్కడ in stage 1 it is the top position, stage 2 top position, stage 3 కి వచ్చేసరికి it goes to the second position, stage 3 third position, and stage 4 it's like fourth position, stage 4 it is third position, and stage 5 it is first position, and stage 6 it is like second position. So please mention with the arrows and observe the path of symbol S0 in the reverse direction lo observe chesukovali and write down the corresponding code word. If you observe S0 path, I have mentioned it with the dotted lines, you can see it is 1, and wherever you have the assigned value, take that value. Otherwise, no need to take any other values. Meeku value assign chesi unte adi teeskuntaru. Otherwise, there is no need of collecting the corresponding term. So here it is 1. Follow the path in the reverse direction. Next 0. That's all. So 1, 0 is the code word for S0. 1, 0 is the code word for S0. Similarly for S1, can any one of you tell me what is the code word for S1? Observe the path of S1 in the reverse direction. Reverse direction lo observe cheyali. This is 1. Next. This is 1. That's all. 1, 1. So S1 code word will be 1, 1. Please check that. This is 1, 1. So then after calculation of all the code words, get the code word length based on the number of bits present in the code word. So if vacheste, then you can easily calculate the efficiency. So average code word length L is summation k is equal to 0 to 6 p suffix k into length of the symbol in bits. Okay, like that you can get the code word length. Okay, then calculate the entropy. I think you know the expression for entropy. It's p log 1 by p base 2. And average code word length ela vastundi meeku the corresponding probability into length. So 0.25 into 2 plus 0.25 into 2, 0.125 into 3. Like that same procedure will continue, except the difference in the reduction process. So in the reduction process only you can find the difference. In all other sense, coding efficiency, everything, almost all the process remains same. Is this okay to everyone, Huffman code? So anyhow, I will tell you one more example in the next class. In the today's class, so with this almost all we can complete this corresponding module of, we can complete the module of chapter 4, part B, first module we can complete. Okay. And tomorrow we can start, we can complete the Huffman coding second example, and we can start the Shannon-Hartley theorem. See, this Shannon's theorem is not not same as Shannon-Hartley theorem. Shannon-Hartley theorem ante channel capacity proof of Gaussian channel. Okay, because Shannon and Hartley are two inventors. This is Shannon's theorem. This is the statement provided by Shannon alone. That is, R is less than or equal to C, where R is the information rate and C is the channel capacity. Okay, and the Shannon-Hartley theorem ante, that is the capacity, those two inventors combinedly calculated the capacity of a Gaussian channel as C is equal to bandwidth log 1 plus SNR base 2. I told you this example problem in the module 1, module 1 or 2, I think. Okay, so that problem I told you, and the proof we will study in the 4th chapter, last module. Okay. So we can continue the class in the next class. So any doubts? Okay, any doubt?